Your essential question, what are compositions of functions and how do you work with them? So just a review on compositions of functions. We did quite a bit with this last year, and we're going to review it this year. So what you just saw was a pebble dropping into a pond. So that is just like an example out of your book that we're going to go over right now. If you drop a pebble into a pond, you get a circular ripple that extends out from the drop point. The radius of the circle is a function of time. So the radius of the circle is a function of time. The area enclosed by the circle or the circular ripple is a function of the radius. So the area is a function of the radius. Thus, area is a function of time through this change of function. So we know that area depends on radius. We know that radius depends on time. So in this case, the area is a composite function of time. So that's what a composite function is putting two functions together, one inside of the other, right? Because we know that the area is a function of time. So instead of putting r here, I could think of it as 8t. Okay, so this is just like an example. So suppose that the radius of the ripple is increasing at a constant rate of 8 inches per second. That's where that 8 comes from, right? So distance times time or rate times time. Okay, and then the area of the circular region is given by, pi r squared. Okay? So let's say, for example, we say 5 seconds. So in 5 seconds, what's the area of this ripple, of this circular ripple? Well, we need to put the 5 seconds into the radius function, which we get out then 40 inches. Then this becomes the input, right? That becomes our radius, which we then input into the area function, getting out our entire area of the ripple. The way that you would have seen this last year is that we would have said area is equal to a of r of x, right? So we have the outside function a, okay, which we could think of this as a of t or a of x, however you want, whatever you wanted to call the function. And that's our outside function. And inside of that, we're going to plug in the radius function, the input function. Okay, so it's important to understand that, we've got x, which is the input for radius function, and then r of x is going to be our input for the area function. So all in all, we've got area is a function of radius, and radius is a function of time, which is how we get that outside function and the inside function. Okay, moving on. Different ways of writing composite functions. And we've already shown you one of them. So you could say a of r of x. You could say a of, or circle r of x. Or you could say a circle r of x. These all mean the same thing. Okay, so they mean a of r of x. You could also think of it as a composition r, or you could also consider it a of r. Those are all different ways of talking about these three different ways of writing the composition of functions. Basically, what you have to recognize, though, is which is your input function and which is your output, which is your outside function. So which of these is your inside function, which of these is your outside function. And that should seem really familiar to you because when we were talking about transformations, we were also talking about inside function, something being done to the inside, okay, and then something also being done to the outside. So these kind of build off of that idea. Moving on to example 1, okay. Functions f and g. So I guess the most important thing is to figure out which one's your function f and which one's your function g. This is my function f, this one's my function g. We want to find f of g of 30, showing on copies of the graphs how you found this value. Okay, so you're always going to start with the inside first. Okay, so I want to do this first. Then I'm going to work my way to the entire outside function. Okay, so first you do the inside piece. Okay, so I have to figure out what g of 30 is. Now they've already drawn an arrow for me here, and then I'm going to do my best. It might be helpful to have a straight edge to try and figure out where that crosses. So I'm going to say it's approximately 2.8. Okay, so I know that g of 30 is approximately 2.8. Okay, so now what I need to figure out is f of 2.8, because that 2.8 goes right in here for g of 30. Okay, it takes up this whole thing. This whole thing becomes 2.8. So f of 2.8 now, so now I'm going to go to my f function. If I think about 2.8, maybe that's here. Draw myself an arrow up. And then draw myself a line back over here. So I'm going to get super close to 200, but it's probably a little less than 200, so I'm going to say approximately 190. Now, when your book did this, they got approximately 180. So we rounded a little bit. When we're rounding, we're not always going to be perfect. So therefore, I can say that f of g of 30 is equal, or I'll say approximately, is approximately 190. Example 2, composite functions from tables, and you've kind of been doing this for a while now in our explorations. So we've got functions f and g are defined only for the integer values of x in this table, so 1 through 6. For A, we're going to find f of g of x for the 6 values of x in the table. So what I'm going to do on here is I'm just going to draw myself another column, and I'm going to call that f of g of x. All right, so the first one's going to be f of g of 1. It helps me to write this out. So when I think about g of 1, if I plug 1 into g, I get 5 out. So really what I'm looking for is f of 5. Well, f of 5 is down here. If I plug 5 in, I get 0 out. Okay, so that one's done. Next, I'm going to do f of g of 2. Okay, so starting with the inside function, g of 2, if I plug 2 in into g, I get 3 out. So really this is going to be f of 3. That inside piece turns into 3. So now I'm looking at my input being 3, plugging that into f, I get 6 out. Not too complicated, hopefully, especially if you write it out and think I'm always working inside out. So the next one's going to be f of g of 3. Where am I getting these inputs? From the x value. Okay, so I'm going to start with g of 3, plug 3 into the g function, I get 2 out, which really gives me f of 2. And f of 2 is up here, so 2, plug that into f, I get 4 out. All right, next I'm going to do f of g of 4. Okay, thinking about g of 4, so when I plug 4 into the g function, I get 1 out. So now I've got f of 1. Okay, f of 1, go back up here. If I plug 1 in to f, I get 3 out. Next is f of g of 5. Plugging 5 into the g function, I get 7 out. So this becomes f of 7. Okay, now is 7 an input option? No, not for either of these functions, right? So I can't find f of 7. It does not exist. So you could write does not exist. You could write undefined. I'll write that. You could write none. Your textbook has been writing none. And why is that? Well, 7, or g of 5, is not in the domain of f of x. So I'm going to write g of 5, which equals 7, not in domain of, and I'm running out of room, f of x. Okay, so that would be a good reason why it's undefined. Sometimes in your textbook, they'll expect you to explain, or on a test or a quiz, I'll expect you to explain why it's undefined, or why it doesn't exist, or why you wrote none. All right, moving on. Let's do f of g of 6. So I plug 6 into g. I get 4. So now my inside function evaluated to 4. So I get f of 4. I plug that into f, and I get 2 out. Awesome. So A is done. Okay, so maybe I'll draw a little arrow here that I did it right there, instead of creating a new table. All right, now for B, I'm going to find g of f of 2 and show that it does not equal f of g of 2. All right, so g of f of 2. Okay, well, let's start with what does f of 2 equal? So going into my input, going to the f function, put 2 in, I get 4 out. So really this becomes g of 4. And what is g of 4? So putting in 4 into g, I get 1 out. Well, what was f of g of 2? Okay, so f of g of 2 was actually equal to 6. Are these equal? These are not equal. You can see that these are not equivalent. Okay, so I was showing that, and I'm also showing that. Moving on to example 3. Now, composite functions from equations. This is what you guys really, really like to do. We did a lot of this last year, and people always struggle with it. So hopefully this year it becomes a little bit more solidified in your mind how to work with these. All right, so we're going to find we have two functions. Let's start with that. F of x and g of x. Those are your two functions. And we are going to find f of g of 4, f of g of 0, and f of g of negative 1. So f of g of 4. So starting with that inside function, okay, so figuring out what g of 4 is might be helpful for us, okay? So why don't I go over here to the side. Actually, I should write an A here. I'm going to go over here and I'm going to figure out what g of 4 is. Well, g of 4 is going to be 2 to the 4th power, which is 16. So f of g of 4 really becomes f of, instead of g of 4, I'm going to put 16. So now f of 16, well, let's see, I have to actually plug that in here. So f of 16 becomes 3 times 16, right, because there's my f function, plus 5, which is 48 plus 5, I think, is 53. Okay, let's figure out another one. I think we need to do f of g of 0. I'm going to go over here because I'm going to run out of room. So f of g of 0. So the first thing I need to figure out is what is g of 0. I'm going to figure out all my g's right here. So g of 0 will be 2 to the 0 power, which is 1. Okay, so f of g of 0 becomes f of 1 because g of 0 is 1. Now plugging that back into f, you get 3 times 1, right, plus 5. So I'm getting 8. Let me circle those. Okay, and then the last one I need to do was f of g of negative 1. Okay, well, I'm going to come over here and figure out what g of negative 1 is. This is kind of my side work area here. So this is 2 to the negative 1, which is actually 1/2. All right, plugging 1/2 into f. So this is really f of 1/2. F is 3 times x. X is now my 1/2 plus 5. So I get 3/2 plus 5. Instead of writing 5, I'm going to think of that as a fraction. Multiply top and bottom by 2, 10/2. So it looks like I get 13/2 or 6.5. All right, moving on to B. Now we're going to find g of f of -1 and show that it's not the same as f of g of -1, which was 6.5. Okay, so g of f of -1. Now you should be thinking to yourself, I'm just kind of plugging in the reverse, right? I'm going in the reverse order. Okay, so something should be, hopefully standing out to you. If you plug functions into each other, you should know something about those two functions if something happens. But we'll get to that in a few minutes. So I'm going to start with what is f of -1. F of -1, let's see, I got to plug it in here. So it's going to be 3 times -1 plus 5. So -3 plus 5 gives me 2. So now this actually becomes g of 2. Okay, g of 2. Oh, let's see, let's write equal sign over here. G of 2, well, that's really going to be 2 to the second power, which equals 4. So as we can see, these two things are not equivalent. All right, and then we've got C that we need to do. All right, so C. Find an equation for h of x equals f of g of x explicitly in terms of x. Okay, so we're going to find this equation basically using these two equations where you have x being your input. All right, so f of g of x basically means that I take the f function. Wherever I see an x, I'm going to put the g of x function. Okay, so my f function, let's see, am I on the screen? Yes. Well, my f function is 3x plus 5. So that's my outside function. Wherever I see an x, I'm going to plug in g of x. So really this is going to be 3 times 2 to the x power plus 5. So again, my f of x function is my outside function. Wherever I had that x, I put g of x, which is 2 to the x power. Okay, so from there, show that h of 4, oh, and I should call this is going to be my h of x function. Because we created a new function. That's why we have all these function names, because we come up with so many different functions. Show that h of 4 agrees with the value you found for f of g of 4. So h of 4 is going to be 3 times 2. My 4 goes for my input, plus 5. So let's see, that's going to give me 16 times 3 is 48 plus 5, which is 53. Does it match up what we found for f of g of 4? In fact, it does, right? These are exactly the same. So we can say equals f of g of 4. Or you can put a check mark, or you could draw an arrow, okay? But either way, it checks out. Okay, working with the same exact functions, now we're going to do a little bit, we're going to plug a function into itself. So f of 2. So I guess it would be important to first figure out what f of 2 is, right? So I'm going to figure out what f of 2 is. Well, f of 2, I need to plug 2 in, so I get 3 times 2 plus 5. So I'm getting 11. Now I'm going to take that 11, and I'm going to now plug that in as my input to f. Okay, so really I get f of 11. Well, that's 3 times 11 plus 5. So it's going to give me 38. So that's A. Let's see, I'll just go A here. This is all A. All right, now B. So for B, I've got, oh boy, I've got 3 functions happening here. So I want to work my way from the very inside out, okay? So starting with, what is f of negative 3? Well, f of negative 3 is 3 times negative 3 plus 5. So it's negative 9 plus 5, which is negative 4. Okay, now that gets plugged into right here. So what I now have is I have f of g of negative 4. All right, well, let's see. I'm going to start with figuring out, actually, I'm going to go over here. Let's figure out what g of negative 4 is. Well, that's 2 to the negative 4th, which hopefully you all remember this. This becomes 1 over 16. Okay, so really, this then, f of g of negative 4 really becomes f of 1 over 16. Okay, so f of 1 over 16, I'm going to now plug 1/16 into x. So that's 3 times 1 over 16 plus 5. So I get 3/16. It might be easier if I just go ahead and make these equivalent fractions. So this is 5 over 1, 16/16, so it's going to be 80/16. So I'm going to get 83/16, which is actually, if you put that into your calculator, you get, or if you divide it out by hand, you get 5.1875. So that's B. Let's see, let's go ahead and call it B here. All right, last example. Example 5. So we've got the function g, and that's got a domain between 2 and 7. We also have function f, and that has a domain between 1 and 5. Okay, and we're going to do whatever they tell us. So they want us to show on these copies of the graph what happens when you're trying to find f of g of 6, f of g of 8, and f of g of 2. All right, so for A, we'll go ahead and we'll mark this up, but I think I'm going to come down here and do a little bit of writing. So for A, I want f of g of 6. Now what's going to happen when I do that? So first of all, let's go to the g function. We want g of 6. So when I plug in 6, looks like I get 3 out. Okay, so this really becomes f of 3. And so now I'm going to go to the f function, plug 3 in. Plug 3 in. Looks like I get 2 out. So that's what they mean by show on your copies of your graph. Like actually draw a little, you can put it as arrows or just lines. So it looks like I'm getting 2. All right, let's try the next one. So the next one was f of g of 8. Okay, so let's see what's happening. F, I want to plug 8 into g. So the problem is 8 is not in the domain of g. Okay, so this is one that's going to not exist. I'm going to put DNE, does not exist. Because 8 is outside g's domain. All right, and then we've got one more, I think, to do on that. F of g of 2. F of g of 2. All right, so starting with g of 2, we're going to go to the g function. I'm going to put in 2. It looks like I get negative 1 out. So this really becomes f of negative 1. I should mark that up on my chart because that's what, or on my graph, because that's what they asked me to do. Now I'm going to plug negative 1 into f. So let's see, negative 1, is that in the domain of f? Okay, so this is another one that does not exist. And the reason for that is that negative 1 is outside f's domain? Okay, so A is done. B, we're going to make a table of values of g of x and f of g of x for integer values of x from 1 through 8. If there is no value, write none. I think I'm going to write does not exist, DNE. From the table, what does the domain of function f of g seem to be? Okay, so I'm going to come up here. I think I have enough room. So this is going to be B. I'm going to do an x column. They also ask for g of x. And they also ask for f of g of x. So I'm going to have those 3 columns. Let's see, we're going to do 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I'm also going to have... Alright, so g of 1... Well, g of 1 does not exist, right? It's outside of the domain. The domain starts at 2. So then f of g of x also cannot exist. All right, next one, g of 2. Well, g of 2 is negative 1. So f of negative 1 is really what I'm looking for here, right? F of negative 1, okay? Because I'm going to plug that g of x into f. So f of negative 1, well, that does not exist, right? That's not in the domain of the f function. Okay, let's go to g of 3. So g of 3 appears to be 0. So now I'm going to plug 0 in to the f function. F of 0, once again, outside of the domain. The domain starts at 1, so this does not exist. Okay, let's move on to 4. So g of 4 appears to be 1. Okay, so then that's f of 1, which appears to be 6, or is 6, not appears. Moving on to g of 5. There's 5. That looks like it's 2. Plug that in, so f of 2, well, that appears to be 4. G of 6, which is here, well, it looks like we've already done that one. G of 6 ended up giving us 3. Plug that in, so f of 3 ends up giving us 2. G of 7 is 4. F of 4 is 0. And g of 8, well, that's outside the domain, so that does not exist. And therefore, I can't plug anything into f of g of x, so I'm going to end up with a does not exist as well. Okay, so let's see. From the table, what does the domain of function f of g seem to be? So where does it look like my inputs work? So, my input 1 doesn't work. Input 2 doesn't work. Input 3 doesn't work. So looks like I'm between 4 and 7. So let's see. I'm just going to put it right here. X is in between 4 and 7. All right, moving on to C. Here are our equations for g of x and f of x. That was nice of them. They didn't make us come up with it. And then they've given us our restricted domains. We have to plot f of x, g of x, f of g of x on our grapher. And does the domain of f of g confirm what you found numerically in part B? What is the range of f of g? Plotting into my graph, let's see, g of x is x minus 3. And I'm going to divide that by the Boolean variables. So x needs to be greater than or equal to 2. And it also needs to be less than or equal to 7. Then I'm also going to do f of x, which is a negative 2x plus 8. Now that's going to have x greater than or equal to 1 and x less than or equal to 5. Now, in the last one, I need to also graph f of g of x. Okay, so I want the first function, or sorry, the second function here, because this was my f function, as a function of g. So I'm going to do something with vars. So vars allows you to go in and actually just take like y1 and put y2 in it. So you go to yvars. Now I want functions, and this time I want y2 because that's my f function. And then into that I'm going to plug in, I'm going to go back to vars and I'm going to grab y1. So yvars, if you need to write this down so that you have it, y1. All right, so I should get 3 graphs, 2 of which are just like what's on our paper, 2 of which should look just like this, and then a third one who hopefully my domain looks like this. Let's see what we get. Man, that looks pretty darn good, right? Does my domain look like it's going from 4 to 7? It does. So, right here I think is where I'll go ahead and do this graph. And I'm just in the first quadrant with a little bit of negative output, so I'm going to do this. All right, so the first function goes from 1 to 5, 2 to 7. All right, so when we had on the first function, when we had 2 as our output or input, we were out to negative 1. And then when our input was 7, we appeared to be at 4. So this is going to be my g function. Okay, now I'm going to do my f function. So when I was at 1, my output was 6. And when I was at 5, my output looked like negative 2. You could use color to help out with these. Maybe a ruler too. I'm kind of in a hurry though, so I'm not going to pull out my ruler. Okay, there's f and g, and now I need f of g. Okay, so it looks to me like I've got x between 4 and 7. When x is 4, my output is 6. And when x is 7, my output is 0. So this is f of g of x. Awesome. Okay, last thing. Oh, did I do everything? I don't think so. Confirm what you found numerically in part B. I think we just did that. Confirmed it. I think, is that right with the graph? Does the domain of f of g confirm what you found numerically? Yes. Okay, we found that the domain was going to be between 4 and 7. So we'll say yes, domain same. And now we need the range. So the range looked like I got somewhere between 6 and 0. So we'll have f of g of x in between 6 and 0. All right, last part here, we're going to do D. We're going to find the domain of f of g algebraically and show that it agrees with part C. Okay, so D. We want the domain of f of g of x. All right, so here's how you do this. First thing you do is you take the input and you write that in the domain of f. Well, the domain of f was between 1 and 5. Okay, so I'm going to write the steps here. Write g of x, which happens to be my inside function, in domain of f. I'm going to get rid of my calculator here. I don't think I need that anymore. Okay, now I'm going to take g of x, and I'm actually going to sub it in here. So I'm going to take the x minus 3 and plug it in for g of x. So I'm subbing x minus 3 for g of x. Okay, my next thing I'm going to do is I'm going to solve for x. So add 3 to all sides of these inequalities, okay? So x less than or equal to 8, greater than or equal to 4. So that's what I did. I solved for x. However, x also has to be in the domain of g. Okay, so, but x must also be in domain of g. And that domain is in between 2 and 7. Right? It was in between 2 and 7. So we're looking for the intersection. Okay, so we need to find intersection of the two domains. So the intersection of these two domains here, 4 is greater than 2. So 4 can be our smallest. And 8 is bigger than 7. It can only go as big as 7. So this is the domain. So let's see, therefore, domain of f of g equals this.